This is 6.2 notes transforming random variables. Let's say we have a dice game where you score 0 points for rolling a 1, a 2, or a 3, 5 points if you roll a 4 or a 5, and 50 points if you roll a 6. So you have a 1/2 probability of rolling 0, of scoring 0, a 1/3 probability of scoring 5, and a 1/6 probability of scoring 50 points. So if you wanted to make a distribution graph of this distribution, we would have 0 with a 0.5 probability, and we would have 5 with a 1/3 probability, and then way over here we would have 50 with a 1/6 probability. Now, to find the mean and the expected value, which of course is the mean, the variance and the standard deviation of the number of points scored in the game, we would use our formulas for expected value. So expected value of x, which is the same as the mean of x, and actually I'm going to write that the other way around just because it suits my purposes better to do that, would be each of the values, 0, times its probability. So 5 times 1/3 plus 50 times 1/6. And if you calculate this, then you would find out that that was 10 points. It is important to use units here because we are talking about a certain context. To find the variance, and actually let's stop and talk about what this means. So if I played the game many, many times, and I'm going to say many, many because this is the very long run probability. If I played the game many, many times, I would average about 10 points per game. Now notice that I would never score 10 points on any one game. So this is just the average over the long term. Okay, so we have E of x is equal to 10 points. Now let's find the variance of x. So variance of x then is each of the values 0, 5, and 50 minus the mean squared and then times its probability. And we add those up. So 5 minus 10 squared times 1/3 plus 50 minus 10 squared times 1/6. And when we add this all up, we would get 325. Now the units on this, since we have squared all of these differences, notice each of these is the difference between how far away each value is from the mean. We square those to make them all positive, and then times the probability of them happening. This ends up being points squared, which doesn't really help us when we talk about spread so much because we would like to have our spread be in the same units as our regular variable, which is in points. So to find standard deviation of x, we just take the square root of the variance of x, which is the square root of 325, and that ends up being about 18.0278 points. Okay, or about 18.03. Okay, so let me just kind of simplify that down. 18.03 points. Okay, so those are our mean. Now what is the standard deviation? This is the typical amount that a score varies from the mean score, which of course is the 10 points. So notice that's quite a bit of variation from game to game. Now we're going to look at what happens when we transform the variable, when I change the game and make the variable something different. So what if I double each possible score? Well, the distribution of that then would look like 2x, and here's the probability. So this, instead of 0, 5, and 50, we have 0, 10, and 100 with the same probabilities, 1/2, 1/3, and 1/6. So we're going to calculate the mean and standard deviation, mean, variance, and standard deviation of 2x. So I'm going to go ahead and pause the video and calculate those. So think about what do you think is going to happen when I do the mean, the variance, and the standard deviation of 2x. How is that going to affect those quantities if we double all of the values? When we calculate these three quantities, we find out the expected value of 2x is 20 points, which is twice as big as the expected value before, which makes sense. If I've doubled all my points, then my average should double. That makes sense. The standard deviation is also double, which should also make sense, because if you look at the original distribution here, the range of values from here to here is 50. If I change these values to 0, 10, and 100, then the range would be 100. So if the range is double, we'd expect that standard deviation to be double. So we have expected value, or the expected value, I'll just say mu and sigma are both, so that's sigma for standard deviation, are both doubled. Now what about the variance? The variance isn't doubled, it's 4 times as much, and the reason it's 4 times as much is, remember, is it's the standard deviation squared, so that should make sense. 4 times 325 is 1300. So after I take the square root of it, then that gives you the standard deviation, which is doubled. Now what happens if you subtract 5 from each possible score? So in other words, we start with the original scores, not the new scores, but the original scores minus 5. So what's the probability of x minus 5? Actually, I'm just going to write probability. I think that would be a better way to write that. So my original was 0, 5, and 50. So now it's going to be negative 5, 0, and 45. The probabilities being the same. So stop the tape once again, or stop the video once again, and calculate those three probabilities, and let's see how they are the same and different from the original probabilities. Or the same and difference, I should say, from the original mean and standard deviation. Notice that expected value, as expected, is 5 points instead of 10 because we've subtracted 5 from each score. So the average score is 5 points less. But the variance and the standard deviation are no different from the original distribution of scores 0, 5, and 50. Why is that? Well, if you look back at the original range of scores here, the range is 50. If I were to change this to negative 5, 5, and 45, notice the range from negative 5 to 45 is still 50. So the spread hasn't changed. The spread has gotten greater when we went from 0 to 100 instead of 0 to 50, but when we go from negative 5 to 45, it's no different than 0 to 50. So there is no difference in the range. So our measures of spread are no different. So how could we summarize this as far as transformations go? If we multiply or divide by a constant, so let's just call that constant b because I think that's what the book calls it. If we are to multiply our random variable by a constant, then all of our measures of center and any other measures of location, for example, the maximum value, the minimum value, the mean, the median, anything is going to be multiplied by 2. So you'll notice here that when we multiply by 2, each of the values, so any measure of position, including the mean, is going to be multiplied by 2, and the range is doubled, so the standard deviation also, so any measures of spread are also multiplied by 2. So if we multiply or divide by a constant b, we are going to multiply, I need to spell that correctly, multiply or divided by b. If the measures of spread, also multiply or divide by b. Now notice variance is times b squared, because variance is the square of standard deviation, so variance would be multiplied by b squared. But everything else, or divided, multiplied or divided by b squared. The shape of the distribution, so notice it doesn't really matter how I rename these values. It's still going to have the tallest bar here, then this one, whether it's 0, 5, 100, 0, 10, 100, or negative 5, 5, 45. The shape of the distribution does not change. So no change in the shape. Now, if you add or subtract a constant, let's call that a. Measures of center are going to change. You're going to add or subtract a. Measures of spread, however, when you add or subtract, they merely shift right or left. So let's say, I can kind of illustrate this, I think, if I think about this. So let's say we have this little distribution here. Let me put this all together, make sure this is all one thing. Okay, so if I just shift it left or right, notice it doesn't change the spread at all. But if I were to stretch it, let's see if I can stretch it. Well, that isn't a good example. I wanted to see if I could just sort of stretch it sideways without making it bigger, but that doesn't actually work on here, so never mind on that. But the measures of spread do not change when we add or subtract. We just shift left or right. So there's no change here and no change here. Actually, I think